This is the second half of section 9.4. It's the other shortcut called the difference of two squares, or DOT as we've abbreviated it. The difference of two squares happens when you have something called conjugates. Conjugates is a new word. Conjugates are when you have two binomials that are exactly the same except one's a minus and one's a plus. Our examples here are all examples of conjugates. Well, let's take a look at what happens when we FOIL this. 2x times 2x is 4x squared. Outside, positive 6x. Inside, negative 6x. Last, negative 9. What do you notice about our middle two terms? They're exactly opposite. So, they cancel, leaving us with 4x squared minus 9. That's why this is called the difference of two squares, because each one is a square and it's the difference in between. Let's look at a general question. A times A squared. Outside, AB. Inside. Now, on this one I want to take a moment and emphasize we want to write our numbers in letters always alphabetical, so minus AB. And then last, minus B squared. Once again, our middle two terms cancel each other out, leaving us with an answer of A squared minus B squared. This is our general form for the difference of two squares. So what happens to the middle two terms? If they're conjugates, they cancel. So what pattern do we see? It's the first term squared minus the second term squared. So let's use that pattern to solve these next problems. Remember, this only happens when they're conjugates. 7x plus 5, 7x minus 5. What's the answer? Let's jump right to it. 49x squared minus 25. The middle terms canceled out. Number 10, 9x squared minus 64. Number 11, 36x squared minus, do you remember what 12 squared is? 144. And our last one, 4x squared minus 1. If you recognize that they're conjugates, the difference of two squares are very quick problems. Today's perfect square is 17 squared. And 17 squared is 289. I remember that. 7 times 7 ends in a 9 because it's 49. And 4 times 7 is 28, so it's 289. That's how I remember what 17 squared is.